All right, I have a new project called Shapes, and in that I'm going to create the project we talked about. So the first thing I'm going to do is create an interface called Drawable. And I'll do New, Class. I'm going to give it the package name of com.sparko. And the name Drawable. Oop, I'm in the wrong spot. I started a class instead of a interface. So that's you'll probably do that a couple of times too. Instead of here, when doing interface, you'll see a very similar looking dialog here. So in the namespace com.sparko, I'll create the interface called Drawable. Okay, so instead of having class here, we have the keyword interface, otherwise it's identical. And within that, we can put our method headers. So any methods I have within here never have any method bodies. They only have method signatures. So their visibility, which is always public, their return type, their name, and their parameter list. So that's drawable. The next thing I want to do is printable. So another interface, printable. And within that, I need a method. Also, just an abstract method that is the signature. So all methods that we have so far in interfaces are abstract ones. That is, we know what they look like from the outside, but we don't have any implementation yet. Next, we'll implement a class. So I'm going to do circle. So now we have the public class circle. I'm going to say implement printable. Save that. In fact, I'll save all, Control-Shift-S. With everything saved, we now have an error. And the error will be that we haven't implemented printable yet. So, saying that you implement an interface can be viewed as implementing an abstract method, but in more plain terms, it could be used as saying you're implementing or fulfilling a contract you made. I promise I'll implement the printable method. Therefore, any methods that are declared as abstract methods in printable, we need to go ahead and develop in any class that implements printable. I'll click on the red X here, and Eclipse will help us out. Add implemented methods. So it overrides them, it adds the method signature, and it adds a body, and it adds to do for us, auto-generated method stub. Of course, Eclipse doesn't know how to write the code. I'll write some very simple code here. All right, let's do one other method. I'm going to return to my default perspective. This time I'm going to implement a class called rectangle. And instead of waiting until I drive the class, I'm going to add an interface here. And here we have that. So the first time I did a class and I didn't do the interface here in the initial creation, I added it as I typed. Here I'm going to do the initial creation. And Eclipse knows to do the right thing. That is, we implement printable. Therefore, we have a contract that says we will implement the print method exactly as printable says it, right? Same return type, same parameter list, everything the same. That's the same rule for override. And that's the same rule when you promise you will implement an interface. Okay, finished the implementation. Rectangle now implements printable. I'm going to modify code a little bit. I'm going to say implements printable and also implements drawable. Now this becomes a comma-separated list, and you can implement as many interfaces as you want to. That makes interfaces very flexible compared to inheriting from classes where you can only inherit from one concrete class. All right, now we have the same thing. That Eclipse will notice the error, and we need to add an unimplemented methods. I'll go ahead and implement this one. Now I have very simple code, one of which prints a rectangle, one prints a draw rectangle. So rectangle implements both printable and drawable, whereas circle I'm going to leave as just implementing printable. So it doesn't have as many capabilities as rectangle has. I've noticed an error here. Let's take a look at that. All right, just needed to be saved. Now let's add a main method here. And now I'll add test code to test these two classes that I've created. So here's the implementation here. I have my test driver, I have main, I have printable declared here. So it's declaring using the interface. So it can declare using the interface, but you can never create an object using an interface. That is, you can't do new printable. You can declare that way. That's really part of the is a printable. A circle is a printable. A rectangle is also a printable. Notice I used the same object handle here twice, once as a circle, once as a rectangle. This also shows polymorphism and inheritance via, this time, interface inheritance. So only a concrete class can be used to create an object. That is, a concrete class has to be on the right side of a new, right? You can declare an abstract or an interface as the object type, but you have to, when it comes to object creation, you have to use a concrete class. So we have a circle and we have a rectangle. Remember, rectangle, a little bit fancier than a circle. It implements both interfaces, whereas a circle just implements printable. A rectangle implements both, and we'll show that in a little bit. So this do print takes a printable, so it can it'll either work with a circle or a rectangle. Here we have the do draw drawable. In a moment I'll use that. Let's run this, and we just have print circle, print rectangle. And now since rectangle is a drawable, we can also use it to do this. But it's declared as a printable. So we won't be able to call drawable with it because the compiler will object to it. The compiler will say, that's a printable, not a drawable. Even though when we instantiated it, we instantiated a rectangle. It is a printable and a rectangle, but remember, the Java compiler does not do dynamic runtime analysis. The Java compiler only does static fixed analysis. Therefore, the runtime state of the object, at this point shape, is different from the view of the compiler's view of the object. Okay, I fixed up this code from the compiler's point of view now. That is, I called doDraw with a rectangle. I haven't changed shape at all. It's still declared as a printable. However, now I do a runtime cast to a rectangle. This is called doing a downcast. Since it's a printable, it's casting down the object hierarchy. Now, the compiler can't check to see if this is legitimate or not. And the very next thing I do is create a new circle, and we then downcast this shape and call doDraw on it. Again, the compiler can't check this. This will be a runtime error when it runs. Let's set a breakpoint here. We can see this here, and we'll run it to this breakpoint. So we printed the circle, we printed the rectangle. Now we're going to draw the rectangle. I'll trace into. And you can see it had no problem with the cast. This is now cast as a drawable because, as we've seen, at runtime it really is a rectangle. We haven't lied to the compiler. Now in this case, we've lied to the compiler and we're going to pay the price with a runtime error. So, circle cannot be cast to a rectangle in module shapes. So the downcast failed in that case for clear reasons. Let's take a look at our object hierarchy again. So this is what we've implemented. We have a drawable interface, a printable interface. I made the rectangle inherit both from drawable and printable, whereas the circle is just a drawable. So, introduction to interfaces in Java, a very important topic. It's all over the standard library, interfaces. Interfaces are something that are central to your work. Thank you.